Alright, so now we're going to take a look at dividing decimals using the standard algorithm. So we'll begin by looking at this division problem here. We're going to be solving what is 8 and 75 hundredths divided by 1 and 4 tenths. So the first step our in the process here. So I'm going to talk about a couple different things just before we get started. I'll talk about really the process, and that'll be a majority of my focus is kind of how do I solve it. But I'll also layer in a little bit of why are we doing what we're doing. So we'll begin with kind of the how-to, and the how-to is the first step is I'm going to come down and I'm going to place the first number and I'm going to put it inside of this little L-shaped half box, so to speak. And then I'll put my divisor on the outside, which is very familiar for us. If you're new to the standard algorithm, this looks like the beginning of the Big 7. The Big 7 had a line that went all the way down like this, and then we began chunking. Unfortunately, the Big 7 does not work when we use decimals. It's really just good for whole numbers, and it becomes kind of training wheels for understanding how the standard algorithm works. So while the Big 7 has tremendous value to what we do in terms of laying a foundational understanding of division, at this point it's really time to take those training wheels off and transition to the standard algorithm. So here we go. Step one, we're going to have a little pre-work when we look at this. Is we need to get our divisor, we need to get 1 and 4 tenths, and we need to turn it into a whole number. So step one is we're going to take a look and say, well, how can I get that to a whole number? Well, there's a strategy here, and then I'm going to explain that to you first, and then I'm going to come back on the back end and say, well, here's why that works. So the strategy is that I simply take the decimal. It needs to move one place to the right so that 1 and 4 tenths becomes 14. Now, whatever I do to the divisor, I must do to the dividend. So I move the decimal over one place to the right. Now I want to move the decimal on the inside one place to the right, and therefore it becomes inside 87 and 5 tenths. Now immediately I also want to go ahead and bring that decimal straight on up, because in my answer that's where my decimal will be. So that's what I kind of call, that's my pre-work to this problem. Now let's take a time out from this problem and just look at, like, why does this work? How does this work? So let's think about this problem right here. What if I had 9 over 3? Well, we know that from our unit and fractions that this is also representative of 9 divided by 3. Well, that would equal 3. So what if I were to multiply both the numerator and the denominator times 10? Well, if I multiply each one times 10, each digit moves a place to the left, and the 9 becomes 90. The 3 becomes 30, which means as a fraction this looks like 90 divided by 30, which also equals 3. Well, what if I multiplied that number by 10? And I multiply both the top and the bottom, both numerator and denominator, by 10, and now I'm looking at 900 divided by 300, which also equals 3. So regardless, as long as I am multiplying both the dividend and the divisor by that base number of 10 or 100, it could be, because that was really, I multiplied this by 100 from here, that the answer is going to come out the same. So in order to get a good number to work with, I needed to multiply the dividend and the divisor in my original problem by 10, so that now I'm dividing by 14 and not 1 and 4 tenths. So it will not, although I impact on the algorithm part, the actual numbers being used, and they are a little bit different, it's not going to change the outcome of my answer. So that's a little bit of the theory behind why I moved that decimal. In fact, I continue to stress upon you, the decimal never moves. It only moves in our strategies, but it's the digits that shift to the left and to the right in the place value chart. So we've got our strategy in place. We've done some pre-work. Now it's time to go to work. So the first thing I'm going to do is I'm going to look at 14, and I'm constantly going to be asking myself, how many groups of 14 can I get out of a certain number? I'm going to begin with, how many groups of 14 can I get out of 8? I begin with the farthest number to the left. In this case, it's the 8, and the answer is none. I can take no groups of 14 out of 8 because it's simply too small. At that point, and that's going to be common in that first number, then I'm going to widen my number one place value or one place position to the right. And now I'm going to ask myself, what about 87? How many times will 14 go out of 87? Now here is where, and again, the chunking taught us and made us more comfortable doing this, is that I can step to the side and start thinking about what I know about the number 14. Well, I know that 14 times 5 is 70. 70 is very close to 87, but it's not where I want it to be. I want to go as close to 87 as possible without going over. Now that's one of the big differences in the standard algorithm and chunking, is that the chunking method, it allows me to come a little bit too far under, and I can correct myself on the next step. Not with the standard algorithm. It's more of a precision division procedure with dividing. So I need to even probably come up more. Again, I'm looking, I'm thinking, well, let's try 6. Well, this here is going to be 84. That's a good. So I'm going to place my 6 here right above the 7. So to the right of the numbers that I'm dividing into. And then I know that 6 times 14 is 84. I'm going to write that right below. Again, watch how I'm lining everything up. I want to make sure that everything is working itself vertically at this point. I'm kind of building down and to the right. Then I'm going to find the difference, and my difference is 3. Now this is always a quality check here to check your math. When you see this number, when you get that difference, you're going to stop and ask yourself, is this number less than or equal to, or I'm sorry, is it less than the 14? So your divisor. If it is equal to or greater than your divisor, you need to go back and take another group of your divisor out. For example, if this number right now were, say, 16, well, I would need to go back and adjust and take 7 groups instead of 6 groups of 14 out of that 87. However, for us, we're in good shape. We're at only 3. We're ready to go. So with the 3, the next step is I'm going to take my 5 here and I'm going to drop it down right here beside the 3. And then I'm going to ask myself, how many groups of 14 can come out of 35? Again, if I need to, I can step over here. I know that 14 times 2 is 28. So I'm going to place my 2 up here. 2 times 14 is 28. I'm going to find the difference, and now I'm at 7. Now here's where we get to a point which we've got some left over here, but we are out of numbers over here by up in the top part. So we're out of numbers here, but yet we still have work to do. Well, what we can do, without changing the value of the number, I can add a 0 right there. I add a 0 to my dividend, and then I'm going to drop this 0 down. And now I'm asking, I've got a new number. How many times will 14 go into 70? Well, I can look over here at some of my basic facts that I've jotted down, and I can see 5. So I know that 5 is 70, so 5 times 14 is 70. Subtract. I have 0 left over. My answer is complete. But I want to check. I want to make sure that this makes sense. So it's saying that 8 and 75 hundredths divided by 1 and 4 tenths equals 6 and 25 hundredths. The best way to check and to make sure that your division is correct is you can check division with multiplication. So I'm going to divide my quotient, or I'm sorry, multiply my quotient, 6 and 25 hundredths. And I'm going to multiply that by 1 and 4 tenths. And my goal is that I get 8 and 7,500. So we'll run through this. 5 times 4 is 20. I'm going to regroup my 2. 2 times 4 is 8 plus my 2 is 10. Regroup my 1. 6 times 4 is 24 plus 1 is 25. Again, notice how I'm really intentional about placing 1 digit per box. It helps keep me straightened up. On the second row, I know I'm multiplying that not by the single digit but by a 10. So I need to add my placeholder 0. All of these are times 1, so that's kind of easy to just whip those numbers in. And then I take those two partial products, I'm going to add them up. And look at there, I can get rid of that 0. So these numbers match. So that's a look at the standard algorithm. My biggest advice to everybody is just making sure that we're lining things up and that we're not afraid to step over here and to do our backs. When we come to 14, those aren't always numbers that are just come to you. They're not basic facts. We don't know our basic facts of 14, so you may need to step aside and jot those numbers down. So keep your numbers straight. Don't be afraid to do your side work, and just work the problem, and always check your work. But this is a standard algorithm. I'll post another example of a number that just doesn't end. So check out this video, and we'll have another one posted as well. As always, thanks for listening. Talk to you soon.